my teacher Olimboka Sejuga Masame, and now from our questions, let us assume that we placed this Rignall hygrometer into this room that has a temperature of 20 degrees Celsius. After a certain time, the dew will start to form, and the average temperature of appearance and disappearance of this dew is recorded as a T1. Now we know that at this temperature, the saturation vapor pressure of this moist air of the room will be equal to partial vapor pressure at this room temperature. Now let us see how you can find this dew point. From relative humidity at this 20 degrees centigrade, the room temperature is equal to saturation vapor pressure at dew point divided by saturation vapor pressure at room temperature, T2 times 100%. Now our saturation vapor pressure at dew point is equal to 14 millimeter height of mercury. In order to find this respective temperature at 14 millimeter height of mercury from our tables here, we will consider where this 14 millimeter height of mercury partial pressure is found. This is found between the 13.6 millimeter height of mercury to 15.5 millimeter height of mercury, with respective temperature of 16 degrees centigrade to 18 degrees centigrade. Let us take a look now here, the simple mathematics below. From 18 degrees centigrade to 16 degrees centigrade, we have a change in temperatures. Change in temperature, that is 2 degrees centigrade, and the respective change in saturation vapor pressure is equal to 1.9 millimeter height of mercury. And what will be the change in temperature, a new change in temperature at saturations? That's why we give it as a sub 1 for the saturations temperature for a given saturation interval from 14 millimeter height of mercury to 13.6 millimeter height of mercury. This change also we give it as a change of saturation, sub 1, because this is sub 1 happen within these saturations at dew point. And then this saturations is respective equal to change of temperature T1, which is equal to 0.42 degrees centigrade. Now our dew point now will be equal to temperature at this is 13.6 millimeter height of mercury plus the change of temperature T1, the range from temperature T1, that is with a saturation vapor pressure of 0.4 millimeter height of mercury, that is equal to 16 degrees Celsius from the respective saturation vapor pressure plus this additional degrees Celsius of this interval of 0.4, that is 0.42 degrees centigrade. Now our dew point T1 is equal to 16.42 degrees centigrade for the saturation vapor pressure of 14 millimeter height of mercury. You can see even the small mathematics in sub. Just to find the mass of dry air with the condition of S.T.P. Now from Dalton's law of partial pressure, the total pressure of the air moisture is equal to partial vapor pressure of water vapor at 20 degrees centigrade plus a partial pressure of air at this 20 degrees centigrade. This is total pressure, that is 750 millimeter height of mercury. We minus with 14 millimeter height of mercury, that is saturation vapor pressure. The partial pressure of water vapor at 20 degrees centigrade, which will be equal to saturation vapor pressure at a dew point at the temperature of 16.42 degrees centigrade. here the condition relative humidity is equal to 100%. Now from ideal gas equation, because our air behaves as an ideal gas, is equal to as you can see below, and we must find first the volume at volume at S.T.P, volume of air, dry air at S.T.P. Volume of dry air at S.T.P is equal to 902.3 meter cubic, and our mass of dry air at that is measured at S.T.P is equal to volume of dry air at S.T.P times a density of air at S.T.P, that is equal to 1163.9 kilogram. Now we have to find also the mass of water vapor at S.T.P conditions. Now also we'll find the volume at S.T.P when we are given the volume of the room, the volume of the rooms, and the temperature of the rooms, and the saturation vapor pressure of the room, of moist air at the of the room. Now volume at the S.T.P is equal to 17.2 meter cubic, and our mass of water vapor at the S.T.P is equal to 0.1376 gram or 13.8 kilogram. Okay, thanks for watching. Please like, share, comment. Don't forget to subscribe for more video like this one. Okay, thanks.